Course 3, Lesson 71, we are looking at percent change of dimensions. So this kind of goes along with a lesson that we did just recently when we're looking at percent change. And big things that we're looking at in this lesson, we are calculating dimensions if we are doing a dilation or a reduction, and also looking at how scale factors can change between dimensions, area, and volume. So when we're talking about dilations and reductions, make sure that your wording is correct. We can talk about percent of the original, which means we're taking my original 100% plus a certain percent of increase, which means my dilation is going to be something like 125% or 175% or 225%, meaning that we're increasing by a certain amount above that 100%. So in the first case, 125%, we would be increasing by 25%. Whereas a reduction means we are saying the percent of the original that I have is 100% minus the percent of decrease. Saying something like, if I am decreasing by 25%, that would mean I have 75% of the original, because I have 100% minus 25%. So if we have just 100% of the original, we're not increasing or decreasing. That is the same size. So if we have a percent of the original above 100, that's an increase. If it's below 100, we have a decrease. So let's look at an example here. One square is 50% larger than another square. So the perimeter of the larger square is what percent of the perimeter of the smaller square. So we're asking for what is the percent of the original for that larger square. So if we aren't given dimensions, that's okay. We just need to come up with our own example. So in a certain case, let's say we have drawn a square and we are going to increase it by 50%. So let's say we created the square 4 by 4. Well, if we wanted it 50% larger, that means I want 50% of 4. So 50% of 4 would mean that we have 2, and we add that on top. So our new side length is 6 by 6. That's 50% on top. So 50% larger, I have my original 100% plus the 50% increase. Okay, meaning I have 4 in this case plus the 50%, which is 2. So we get 6. Now the other way we can see this is that's just 150% of the original, which if we're thinking about a scale factor, 150% as a decimal is just 1.5, which is exactly what we need to get from here to here. We multiply by 1.5. So our percent of the original when we're thinking about dimensions is just our percent of the original. Okay, and we turn that into a decimal to find our scale factor. Okay, now let's think about a reduction, or yeah, we'll skip that one. Let's think about a reduction, like if a towel were to shrink in the washer and dryer. So if it shrunk by 10% when it was washed, the area of the towel was reduced by what percent? And it's pretty easy to think maybe it also reduced by 10%. Well, unfortunately, it doesn't work quite that nicely. It doesn't work in that same pattern. But let's try it out on these two towels. So we have our original towel. Let's say it is 2 feet by, I don't know, 6 feet. Sure. All right, a 2 foot by 6 foot towel. And it shrunk by 10%. That means the dimensions went down by 10%. So if my side length of 2 feet went down by 10%, that means that I have, well, 100% minus that 10% means that I have 90% still remaining, or 0.9 as a scale factor. So I would say 2 times 0.9 would be this 1.8. So we now have 1.8 feet, a little bit smaller. And the 6, we're going to do the same thing. 6 times 0.9 would give me 5.4. Okay, so now let's look at these. So what we did was we took our 2 feet by 6 feet, and we multiplied them by 0.9, and so we got 1.8 feet. and by 0.9. So we got 5.4 feet. Those are my dimensions. And that's just a simple scale factor of what do we have remaining. My 90% is what's left over. Now let's think about the area. In the first case, 2 feet by 6 feet, I have an area of 12 feet squared. And if I multiply 1.8 by 5.4, I will end with 9.72. 9.72 feet squared. Now the question is this also a reduction of just 10%? Well, if we took my 12 feet, my original 12 feet, and multiplied it by my same scale factor of 0.9, well, if we do that, 12 times 0.9 is 10.8. So clearly it doesn't have the same scale factor as my dimensions. It must have a different scale factor. Let's see what it is. So I'm going to take my new 9.72 and divide it by my old 12. Well, 9.72 divided by 12 gives me 0.81, meaning that we have the scale factor of 0.81 here between the areas. How can that be? Well, if you see any relationship between 0.9 and 0.81, that would be that if I have a perimeter scale factor of 0.9, like we had 90%, my area scale factor is now 0.9 squared, or 0.81, 81%. So if this is 90% of the original, this is 81% of the original. So this is a 10% decrease, and we have a 19% decrease. Perimeter scale factors and area scale factors aren't the same. We end up seeing that perimeter scale factors going to area scale factors, we have to square them. And thinking ahead, volume scale factor kind of follows the same scale. Instead of squaring it, we are going to cube it. But let's look at another example. The vertices of a square are 4, 4, 4, negative 4, negative 4, negative 4, and negative 4, 4. Sketch the square and its image after 125% dilation, which means I want 125% of the original, which is a 25% increase. So with this, I could use a scale factor from the percent of the original as 1.25. And like we've seen in the past with dilations, I just need to take each of these parts and multiply by 1.25. Meaning, in this case, I get 5, 5, 5, negative 5, and so on and so forth. And I get a couple squares, okay? I get a square that ends up being on a coordinate grid. It ends up being 8 by 8. I'll draw it right here, 8 by 8. Okay, and then we have a square around it that is 10 by 10. The question is, what is the perimeter scale factor? What is the area scale factor? So the perimeter scale factor, if we look, we have a perimeter for the small one of, let's see, 8 times 4, which is 32, and then 40. So we are going from 32 to 40. Meaning, if we figure out what the scale factor is between that, 32 times 1.25 gives me 40. So this is times 1.25, meaning our perimeter scale factor is 1.25. Well, based on what we learned on the other page, my area scale factor should be 1.25 squared, which is 1.5625. Well, let's see if that's true. With the areas, we are going from an area of 64 units squared to 100 units squared. If I do 100 divided by 64, 100 divided by 64, I get 1.5625. That new divided by the original gives me my scale factor. So I get 1.5625. So just like my perimeter scale factor is 125% of the original, which means I have a 25% increase just like we saw on the first page of this lesson. This one is 156.25 of the original, which is 56.25% increase. Okay? Always two ways to talk about these percent changes. One of them is how much do I have of the original, which is always that 100% plus my percent of increase. And then my other way is to just talk about the increase, which is how much do I add on top of that original 100%. Okay, and just a couple more examples here. Now let's talk about volume. So if I have a cube that the dimensions are increased by 100%, well, what is the perimeter scale factor, area scale factor, volume scale factor? And we'll talk about that area scale factor as more of like, you can think about it as just one face on the cube or all of the faces added up. Doesn't matter, ends up the same thing. And let's say I talk about my cube and it's a 2 by 2 by 2 cube. Well, 100% increase means that I have 200% of the original. So, meaning I want 100% on top of this, I get 4 by 4 by 4. So my perimeter scale factor is 2 because I have that 200% of the original. My area scale factor, well, if I look at a face on my first one, the area is 4. On the second one, my area is 16, meaning I multiply by 4 to get there. So my area scale factor is 4, or another name for it is 2 squared. And lastly, my volume scale factor. Volume for the first one is 2 times 2 times 2, which is 8. And 4 times 4 times 4 for the other one is 64. So I multiply by 8, or other known as 2 to the third. This pattern always continues. My perimeter scale factor is just what percent do I have of the original. Area scale factor is my perimeter scale factor squared, and volume scale factor is the perimeter scale factor cubed. We can talk about each of these. My area scale factor, that's 400% of the original, or 300% increase. And volume scale factor is 800% of the original, or 700% increase, because I'm adding that 700% on top. Okay. Let's just look at these last ones here. There are two similar circles. The diameter of the larger one is 40% greater than the diameter of the smaller. The area of the greater one is what percent larger than the smaller? Well, if we're thinking about this one, this is a 40% increase, which means I have 140% of the original, meaning that my perimeter scale factor is just the decimal form of that as 1.4. Well, my area scale factor then is just 1.4 squared, which is 1.96, meaning I have 196% of the original, or 96% increase. Okay? So we are 96% larger than that smaller circle. And lastly, Becky reduced the size of the image on the computer screen by 40%. What percent of the area of the image was reduced? So if we have a 40% decrease, that means I have 60% of the original. So as a scale factor, my perimeter scale factor is just 0.6, meaning my area scale factor is 0.36 because I square it, meaning I have 36% of the original. So I've taken away a lot. I've actually taken away 64%. We have a 64% decrease in the area. All right. Well, I hope this is helpful for your homework and for studying.